G'day chemists. So today we're going to look at two ideas, cohesion and adhesion, and how they relate to water in particular. So our learning goal here is we want to be able to understand the differences between cohesion and adhesion, as well as the forces that cause them, etc., etc. But we also want to be able to talk about what they actually are. And to do this, by the end you should be able to show a diagram or create a diagram showing the differences between the two. So, what is cohesion? Let's start here. Cohesion's the simpler one that you might be a bit more familiar with. It's the sticking together of particles of the same substance. So cohesion is when we have particles that are identical or the same sticking together. Okay, so water particles sticking together, ammonia particles sticking together. Cohesion tends to result from hydrogen bonding, which is why we said ammonia or hydrogen sulfide, as well as water. And you see a really good example of that over here. So here is, in space, a water bubble actually just sticking together. It's sort of, there's nothing there pushing on it trying to break it. And over here we see the mechanics behind that. We have the positive hydrogen being attracted to the electronegative oxygen. And they all stick together. And because of this is why we have surface tension on water. We can also have a surfactant. So in this case, we're talking about things like detergents. And what a surfactant does is it reduces the surface tension of water, which means it interrupts those hydrogen bonds. So it's fair to say it might actually have some other implications as well. But cohesion is reduced by a surfactant because it interrupts the hydrogen bonds. So a force is required to separate water and move through it. And this is because you have molecule A and molecule B, and they're being held together by these hydrogen bonds. So if you want to come down and get in between them, you need to push them apart. And to do that requires force, because you've got to break those hydrogen bonds apart. Which is why we can have small things sitting on the water. So here we see cohesion happening at the surface, and this is why water often has that sort of bubble shape. When we see a water droplet on Earth, we'll always see it like this. And the reason it looks like this one here in space is because there's no gravity. So here gravity pulls the base of it down towards the center of the Earth, whereas in space you don't quite have that. So that's the difference there. And at the edge, you'll have surface tension being caused by cohesion as they're all sticking together. And in the middle of the bubble, or not bubble, droplet, you'll have cohesion holding it all together. Which is why it's why water has a large liquid phase and a few other things. And that's hydrogen bonding. So let's have a look at adhesion. Adhesion is kind of the opposite force. It's the attraction of molecules for one kind, so water, to the molecules of a different kind, like glass. They can be quite strong for water with other molecules that have positive or negative charges. So remember, water has this kind of structure here, where you're like, where you've got the positive end and the negative end. And if you have a surface that is charged itself, water will stick to that. It will hydrogen bond to, or dipole-dipole bond to that surface. And this is what we're saying with the glass here, right? So you've got the water is adhering to the surface here, so which means in capillary action it drives it up. And we've got the meniscus here is caused because gravity is pulling it down, pulling the water back down, but also the surface tension is, or cohesion is holding it together. So we've got cohesion across here, adhesion on the sides, and as wind blows across this way, it pushes air out, evaporates up, and it drives it further up. And this is capillary action. So water moving through a xylem is an excellent example there. Now, this is what this kind of looks like on a molecular level. Obviously not quite, but we have adhesion here on this side, and adhesion over here, and we've got cohesion in the middle there. Now, it's important that we have a polar object here, or a charged object. This is why we have the surface tension across the top, or the meniscus. Alright, I hope that made sense. If it didn't, put your comments in the questions below, and we'll get back to you as soon as we can. Thanks for watching. Bye now.